My name ni Aiman Harith bin Muhammad Saidi.
My name is Rashdan bin Ruslan.
And my name is Waniman Hakim bin Farul Hakim. In this video, we would like to present our mini project for Mr. Shari's subject, Electronic Automation Laboratory. Firstly, we will show you pictures of the whole mini project. Here is what it looks like. The name of the project is Smart Auto Clothesline. You can see every angle in the picture provided. Next, my friend Nick will tell every material that is being used to build the project.
Next, I will explain the materials and equipment that are being used to make our project. Firstly, we use ESP32. ESP32 is the main controller that reads the sensor and controls the motor. Secondly, we use rain sensor module. It's used for detect the presence of rain or water drops. Thirdly, we use stepper motor to move suspension into the roof when rain is detected. Besides, we use motor driver to help the Arduino control the stepper motor safely. We also use power supply 9 volt to provide power to the ESP32 and motor. We also use connecting wires or jumper wires to connect all components together in breadboard. Furthermore, we also use cardboard to design our mini project. And lastly, we use glue gun to fix the components and cardboard in the place to complete our project. Next, my friend Rashdan will tell about circuit diagram of the project.
Hi, I'm Rashdan. I will tell you all about circuit diagram of the project. This is our circuit diagram. The main component in our circuit is ESP32. It used as a microcontroller that process the signal from the rain sensor and control the motor. Secondly, we also have rain sensor module. It used to detect rainwater by sensing the change in resistance when water droplets are present. Thirdly, we have motor driver to drive the motor using control signal from the ESP32. Besides, we also have stepper motor to rotate our belting after rain sensor detect a water. And lastly, we have battery or power supply to provide power to the motor driver and ESP32. Now I will tell about working principle our circuit diagram. When rainwater falls on the rain sensor plate, it reduces the resistance and the sensor module output a low signal to ESP32. The ESP32 detects this signal and sends control command to the motor driver to activate the motor and rotate our suspension into our rooftop. Now, I want to explain about advantages and disadvantages of our project. Firstly, I will tell about advantages first. The first advantage is works automatically. The rain detector can sense rain and take action by itself. People don't need to do anything, like closing windows or turning off watering system. Secondly, low cost and easy to make. The part used is sensor, ESP32, motor driver are cheap and easy to connect. Students can build it easily. Next, I will tell about disadvantages. The first disadvantage is needs power to work. If there is no electricity or battery, it will not work. Secondly, small detection area. It can only sense rain in the small area where the sensor is placed. Lastly, can get damaged over time. Sun and rain can damage the sensor if it is outside for a long time. Next, I will pass to my friend Wan to explain about our project coding.
Now I want to briefly explain the coding that I made. The program that I used to create the coding is called Arduino IDE. Here I have provided several pictures of sketches of coding. These are the pins on the ESP32 connected to the four control inputs IN to IN4 of the L298N driver, which energizes the motor coils, the rain sensor's digital output D0 on pin 33. In other words, IN1 to IN4 control motor directions and steps, whereas rain pin, or in pin 33, reads if there's rain or not. High means dry, low means rain detected. Next, this 2D array defines the 8 half-step sequence used to move the stepper motor smoothly. Each inner pattern corresponds to which coils are energized on or off at each half step. 1 equals to coil is on, 0 equals to coil is off. Next, we'll see void setup. This runs once at startup. Set motor pins as output, set the rain sensor pin as an input, and lastly start serial communication so you can see debug text in the serial monitor. Now we will learn how to program a rain sensor. Look at line 42. This line ensures the motor only moves when the condition changes, not continuously. Line 46 means when rain is detected as low, it calls move motor forward for about 3 seconds or 2700 milliseconds as I program it. Next, line 51, when sensor goes back to dry or high, it moves the motor backward for 3 seconds, or in this case 2700 milliseconds. Next, I will show you how did I program my stepper motor at line 64. As you can see, runs step forward repeatedly for the specified time in milliseconds, then stops the motor after the time expires. Now look at line 73. Same idea, but reverses the step order, rotating the other direction. After that, we'll see how the motor make the half steps. The half steps has two directions. One is for forward and second for backward. Each step energizes coils in order, turning the shaft a tiny bit. The word delay in bracket 8 controls the stepping speed. Smaller means faster rotation. Next, line 99 to 102. This will turn off all coils to stop the motor and at the same time reduce heat. Lastly, line 106 and 110. These will apply step pattern. This program takes one of the 8 patterns from the function steps in brackets and applies it to the motor pins.
That's all for our coding. I hope you guys understand what has been explained by Wan. Next, I will pass to my friend Aiman to show demonstration our project and make conclusion.
Now I will show you guys our project demonstration. When the rain sensor detects the presence of water, the stepper motor will trigger and the pulley will move the suspension into the rooftop. And when the rain sensor is dry, the stepper motor will trigger again and the pulley will move out the suspension from rooftop. In conclusion, the rain detector for suspension works well to stop the system when it rains. It helps protect the machine from water and damage. This project is simple, low cost, and useful for safety and machine protection. That's all from us. Thank you.